Okay, let's graph this rational function. Last set of problems. Let's look in the numerator to identify our x-intercepts. So I have an x-intercept at 1, 2, 3, positive 4, and an x-intercept at 1, 2, 3, 4, 5, negative 6. Okay, so I have those two pieces right there. And I know that both of those x-intercepts will cross because of the multiplicity of the factors. It's both just 1. So both of those will cross smoothly straight through. Now, I have no common factors in the top or the bottom, which is why I have no holes. You should look for that first. But now just look in the bottom for vertical asymptotes. So x minus 2 will give me a vertical asymptote at positive 2. So I'll dash that in right there. X plus 4 will give me a vertical asymptote at negative 4. So we'll dash that in. But there's something special about this asymptote. This asymptote is squared, which means that on either side of this asymptote, my tails are together. So they're either both down like that, or they're both up. I don't know which, but they have to be together because it's squared. Whereas on all my other asymptotes, because the multiplicity of all these factors is just 1, my tails will be on opposite sides, approaching opposite infinities, kind of like a 1 over x graph, where 1 goes up and 1 goes down. It's important information because it's going to dictate what this graph looks like. So I have two more asymptotes. I have x minus 6 giving me an asymptote at positive 6 right here. And I have x plus 7 giving me an asymptote at negative 7, so right here. Okay. Now, what does this thing do? Well, I know that since I have no negatives in my function, I'm going to start positive. I should say my horizontal asymptote is at y equals 0 because the degree of the denominator is much larger than the degree of the numerator. So it's what? It's a degree 1, 2, 3, 4, degree 5 in the bottom, degree 2 in the top. So anytime the degree is bigger on the bottom, you will have a horizontal asymptote at 0. So what now? Well, I was saying a moment ago that I know my first branch over here to the right is going to be fully positive like that because I don't have any x-intercepts and my function is a positive function. There's no negative coefficient anywhere, which means like all of these factors, if you chose a big x value, say like 10, every single factor would be positive, which means we'd be multiplying and dividing positive numbers and we'd get a positive number back. So my right branch has to be totally positive. So that tells me that my left branch has to start down because of the multiplicity of that factor is odd. So I have to start down, I have to go up and approach my x-intercept. I have to cross at my x-intercept, which means I have to cruise up at that other asymptote. Now, my next asymptote, I have to start down because I have to have the opposite behavior of on the left side as I do on the right side of that asymptote, because that asymptote comes from this factor right here, and that factor has an odd multiplicity. But I don't have any x-intercepts here, which means my graph has to turn and come back down. So it has to look like that, which means now I'm at my special asymptote, my asymptote that is squared. Since that tail is down, this tail also has to start down. So I have to start down, then I go up to that x-intercept, I cross and approach that asymptote right there. So the graph's going to look something like that, which means finally on the other side of that last asymptote, coming right here, since the multiplicity is an odd number, and I'm positive to the right, I have to start negative to the left. And so then my graph is going to look like that. So I've identified all of the vertical asymptotes, all of the x-intercepts. My y-intercept is a number, and I'm not going to find it, but you could plug in 0 for x and find your y-intercept. But it should be a negative number. You should see that you do get a negative y-intercept if you plug in 0. So there's that. And that's what we're going to do. I don't know what I'm saying.